Okay, welcome back, class. And today we're going to start 2.1. So this is going to be um, on solutions of linear systems using what's called the Echelon method. And so we're going to show you basically how to do this with both manually and also with the calculator. And so the first thing to start out with is a question. And so here's a common question. How much of each ingredient should be used? And so in this case here, suppose you have animal feed and it's made from two ingredients, corn and soybeans. One serving of each ingredient provides the number of grams of protein and fiber shown in the table below. It says, now suppose we want to know how many servings of corn and soybeans should be used to make a feed that contains 115 grams of protein and 95 grams of fiber. So given this is the table we're using, so here's the number of the amount of grams of protein that's found in one serving of corn and the amount of protein in one serving of soybeans. And then respectively for fiber, we've got 11 and 4. But we've also got this other thing here that says, okay, well, we want also to have feed that has 115 grams of protein and 95 grams of fiber. It says, so we want to know how many servings of corn and soybeans should we use to make a feed that contains that many grams of protein and fiber. And so these are the questions that we're going to answer. These are the types of questions that we can set up as a system of equations and then solving that system of equations to come up with an answer. And so the types of solutions for two equations in two unknowns. So in this section, we're going to be dealing with, hey, if we have a system of two equations where with two unknowns. So the three cases that we can have is that we can have two graphs. The two graphs of the lines intersect at a single point, which means that when we want to solve a system of two equations with two unknowns, we're dealing with lines, right? We're dealing with lines, and we're seeing, well, if those two lines intersect, then there should be a unique solution, one solution to the given system. Okay. Case two, the graphs of the lines are distinct parallel lines. So this means that there are no solutions that will be on both lines because they're parallel, which means they never intersect. And so in this case, this is what we call an inconsistent system. Okay, there is no solution common to both equations, because if there was a common solution, that would mean that the graphs would be intersecting, because if we had a solution for one equation, okay, that was also a solution to the other equation, they would be the same point on the graph. Okay, and so parallel lines don't intersect, so there would be no solution. And we're going to see an example of that as well. 3. Case 3 is the graphs of the line are the same line. In this case, the equations are said to be dependent on each other. They're dependent equations, since any solution of one equation is also a solution to the other equation. There is that, and what that means is that one line is right on top of another line, and so that there are infinitely many solutions. Okay, so what do we mean by a consistent system then? So a consistent system of equations is any system of equations with at least one solution. So that means it could be one solution or many solutions. So in the above, case 1 and 3, would be consistent, where case 2 is an inconsistent case. So here are the examples. So here is a graph, so a system of two equations with two unknowns, right? So two lines. And if there's one unique solution, then they intersect at one point. Here's an example of an inconsistent system where you have two parallel lines that never intersect. And so therefore there is no common solution, and therefore there is no solution to this. Okay, therefore inconsistent. And then of course this is the third case where you have a line that literally is on top of a line. It represents two equations with two unknowns that represent the same line. One way to see this is one line is always going to be a multiple of the other line. That is a way to see that. So now, to solve a system of equations, we're going to transform the system. So the way we do this is working with algebra. So what we do is we use algebraic properties, and when we have a system of equations, we can do certain transformations to that system, and what we end up with is an equivalent system, which means that the solutions of one system is the same as for the other system as well. And so those two systems are equivalent. Well, what we want to do is we want to take a system of equations that looks complicated, and we want to transform it into an equivalent system that is much simpler and easier to solve. And so when we look at these three operations, these three transformations, all three of these are transformations that we can do to a system that will not change the solution set of the system. So what are those transformations? Well, one, we can exchange any two equations. So we can switch or exchange any two equations in the system and it won't change anything. We can multiply both sides of an equation by a non-zero real number, and that will not change the solution to the system. Or three, we can replace any equation by a non-zero multiple of that equation plus a non-zero multiple of another equation, which means we can take equations within the system and add them together, and that resulting equation will not affect the solution set. Okay, so any time we do any one of these three transformations, we will end up with an equivalent system. Okay, and again, an equivalent system is a system of equations having the same solutions as the given system. So let's talk about the echelon method. Okay, so using these three transformations, the echelon method is a systematic approach using these transformations, the three transformations listed on the previous slide. And the goal of the echelon method is to use the transformations so that we get a system of equations that has a triangular form. What do I mean by a triangular form? A triangular form means that if we look at this part right here, it looks like a triangle, meaning that if we line up these variables, notice that there's no x, and so we end up with like a triangular shape. Okay, and why is that easy? Because what we can do is when we have a triangular form, the very last equation is always going to be the last variable equal to a constant, where a, b, and c are constants. And so what we can do is once we know what y is in this case, now we can back substitute and we can plug in c for y, and now we can solve for x and eventually solve for the system. Okay, and that's what we're doing here. Okay, and so let's look at this example here. So let's say we have this system of equations and we want to find a unique solution. So this example has a unique solution. They don't always have a unique solution. So the first thing we need to do is we need to make sure that it is in proper form. So what is proper form? Well, we want to make sure that all of the variables are one side of the equal sign and the constants are on the other. And then we also want to make sure that all the variables line up. And normally we want it in alphabetical order. So we have x's to the left, y's to the right. Okay. And if we had three variables, let's say x, y, z, well, we would have three x's and then followed by y's and followed by z's. Okay. So that's what we're going to do. Now this one is already set up and is in proper form. Okay, so we don't have to do anything with this. So let's look at the solution. So the idea is we want to figure out a way to get rid of this x here. Okay, so we want to find out how to get rid of this x, because if we can figure out a way to get rid of x, then we'll have y, and we could solve for y equal to this. And this is where the transformations occur. So the first transformation that we're going to do is we're going to do transformation 3 to eliminate the x term. Okay, because we want to get rid of the x term. We only want one x term, and anything underneath it we want to get rid of. Okay, so what we're going to do is we need to figure out a way to get the same coefficients here. Okay, so we want to get the same coefficients except opposite signs. So how can we get the same coefficient with opposite signs? Well, we got a 3 here and we've got a 2 here. Well, if we multiply this equation by 3, we'll get a 6. And if we multiply this equation by 2, we'll get a 6. Well, that means we just have to do some opposite value. So in this case here, what they end up doing is we're going to multiply equation 1 by 3. And then we're going to multiply equation 2 by negative 2. And then we're going to add those together. So we're going to multiply equation 1, okay, by 3, and then add that to 2 times the second equation. Okay, so what we're going to do is right here. So we're going to do 3 times this is equal to 36. So we're going to get 6x plus 9y equals 36. And then we're going to multiply this by negative 2. And we're going to get negative 6x plus 8y equals negative 2. And so now here's what our two equations are. And we're going to add this equation to this equation. And these are going to drop out. And we get 17y is equal to 34. And we're going to take this and we're going to replace this equation with this one. Okay. So then what we're going to do is now we're going to leave this one the same. And now this is going to become 17y equals 34. And so now the way we indicate the process is with this notation. So what we're going to do is we're going to take 3 times row 1 plus negative 2 times row 2, and then we're going to take that and replace it with row 2. Okay, so whatever this turns out to be, we're going to use that to replace row 2. And that's what we did right here. So now, okay, now what we're going to do is we're going to use transformation 2 to make the coefficient of the first term equal to 1 now. So we want this to be 1. So what we're going to do in order to make this equal to 1, we're going to multiply everything by 1/2. And so that means we're going to get x plus 3/2 y is equal to 6. Okay. And then we're going to multiply equation 2 by 1 over 17 to make this equal to 1. And so we're going to multiply, or we're going to divide this by 17, and we're going to divide this by 17. And so we're going to get y equals 2. And so then our system, so these are the two transformations we're doing. 1/2 R1, and then we're going to replace it with R1 with that. And then we're going to take 1/17 of row 2, and we're going to replace row 2 with whatever that is. And so this is what we get. So we get x plus 3/2 y equals 6, and we get y equals 2, and that becomes our new system of equations. And so now, if you see it, this is in triangular form. And so now what we could do is we could back substitute, since we already know what y is. Now we could plug in for y, and we get x plus 3 equals 6, so x is going to equal 3. And so now the solution to the system of equations is x equals 3 and y equals 2, or the point 3, 2. So this is where the two lines intersect. And we're done. Now, let's look at the original, the example that I gave at the beginning of the presentation here. So if you look here, here's the two equations, right? Way from the feed example. And so we have, this is the amount of servings, the number of servings of corn, and the number of servings of soybeans. So we know that 3 grams of protein come from corn and 10 grams of protein come from soybeans. And we know we want a total of 115 grams of protein. And then we have the number of servings of corn that give us fiber. So there's 11 grams of fiber here and 4 grams of fiber when it comes to the soybeans. And that we have to have a feed that has a total of 95 grams of fiber. So now what we're going to do is we're going to use this information, and by using the elementary row operations, those three transformations. So how does this work? So we want to use these equations to get rid of this x. Okay? So we want to get rid of x here. So we want to multiply this equation here by some number, and we want to multiply this equation by some number, so that way we can add this equation to this equation and then replace the second equation with that. Okay? Just like we did in the last one. And the obvious choice is to multiply this one by 11 and then multiply this one by -3. And so we'll get a -33 here, and we'll get a +33 here, and then we can add them, and then we'll get a new second equation. Okay? But eventually what you're going to want to do is eliminate this, and then you're going to have a triangular form, and you're going to want the leading coefficients of these two to be 1. Okay? And so what you'll do is when you get that, you'll end up with this system of equations. And then what you're going to do is you're going to back substitute y equals 10 in here, and then you're going to solve for x, and x is going to be equal to 5. Now what I want you to do is go ahead and do that on your own. Okay, and if you get stuck, make a note of that, show me your work, and then also bring it to class and let me know, because this is one that will work in class. But again, you have to show me what you did. Okay. Now, here's an example of where the system of equations would not have any solution. And again, I want you to try yourself and prove that. So here's the system of equations, and what you'll do is when you do those transformations, those row operations, you will end up getting something that looks like this. Now notice that this is a false statement. This is a contradiction. So this is what you're looking at. 0 can never be equal to 20. So what does that mean? Well, this is the y variable, right? They're saying that, hey, guess what? It doesn't matter what y is. There's no value of y that you're going to get to work in the system of equations, because 0 never equals 20. And so this is a contradiction. And since this is a contradiction, it's an inconsistent system of equations. And then this is the case where you have parallel lines. Okay? So anytime you get something like this, that's going to be an indication that you have lines that are parallel. Okay, so again, prove it to yourself. Take this system, do the transformations, and get it to this form. Okay, here's another one. Here's the one where you have infinitely many solutions, right? So you're dealing with the same line. Now notice, first of all, that this line, this equation here, is just the same as this equation, except you're multiplying by -2. Because if you multiply this equation by -2, you will get this equation here. So that's the obvious thing to look for, is if you have one equation that's a multiple of another equation, then they are the same line. Okay, but also beware that you need to be able to prove it using the transformations. So look what happens here when you do the transformations. You will get something that looks like this. And look what you get. You get a true statement. 0 will always equal to 0, which means that in this case, you can make y whatever you want it to be. Whatever y is, it will always be true. So in this case, whatever you make y here, it will also be the same y you will use here. So anytime you get where you have a line of zeros, in this case 0 equals 0, this is always going to be a true statement. This is a consistent system. And this is where you're going to have the same line. Anytime you get 0 equals 0 or a line of zeros or a row of zeros, you're going to have where it's going to be represent the same line. Okay, and that's when you're dealing with a system of two equations with two unknowns. Okay, so either the lines will intersect at one point, or the lines are parallel and will never intersect, or they are the same line and they will always have an infinite number of solutions. Okay, so now let's talk about general and particular solutions. So if we take the last case, for example, this one here. So if we look at this one, let's see what happens here when we try to get a general solution. Because whenever there's an infinite number of solutions, that means we can have a general solution or we can have a particular solution. Okay, so let's be aware of that. Okay. So if we have this system and we solve it for this, let's look at how we would get a general solution. Well, we know that y can be anything. Okay, that's what those rows of zeros. It means that y is a free variable. And what we can do is whatever y is, that will automatically determine what x is. So x is dependent on y in this case, because y is what we would call the parameter, because it is the one that can be any real number. Okay, and in this textbook and in most textbooks, the construction is the system is that and this is where the triangular form comes from, is that the rightmost variable is the one that's going to end up being the parameter. That's the one that's going to be what we call free. It's free to be any real number. So the general solution then would be, well, y can be anything. So the y variable would be y, and then the x variable, which depends on y, is just this. So based on our equation, okay? So the general solution would be this point, would be this form, okay? Now, if we wanted a particular solution, then we would just choose a value for y, and then use that value to find out what value of x would be the corresponding value. Okay, so for example, if y is 5, so y is going to be 5, well, that means this is going to be 9/3 or 3. So the particular solution would be 3, 5. Okay? So now here is the echelon method of solving a linear system. So the first thing is, if possible, arrange the equations so that they are that there is an x term in the first equation and an x2 term in the second equation, and so on. Okay, so you want to line up all of the x variables and then line up all of the y variables. Okay, that's step number one. Step number two is you want to eliminate the x1 term in all equations after the first equation. Okay, so in a system of equations, so here we're using xy. Okay, but let's say instead of xy, let's use a system of equations where we have x1, x2, x3, all the way up to x sub k, or x sub n. Okay, so in this case, what we want to do is we want to line up all the equations so that there is an x1 term in the first equation. We want an x2 term in the second equation, x3 in the third equation, so on and so forth, which means that if we look at the diagonal, along the diagonal, if you will, we will have a non-zero coefficient in the diagonal. Okay, and you'll see an example in a moment. Then what we're going to do is we're going to eliminate all of the x1 terms after the first equation. And then we're going to eliminate all the x2 terms after the second equation. And then we're going to eliminate all the x3 terms after the third equation, and so on and so forth. Okay. And then what we're going to do is we're going to continue in step 5 until the last equation has the form of just a times x sub n equals to some constant. Okay, for the constants a and k, if possible. Okay. And then step 6 is then what we're going to do is after we get it into that form, then we're going to multiply each equation by the reciprocal of the coefficient of its first term. Why do we do that? Because we want all of the leading coefficients to be 1. And then once we do that, then all we have to do is back substitute to find out what the value is of each term, working from x sub n all the way back to x sub 1 where we started. And that's the system. Okay, or that's the method, the echelon method. So let's look at this example here. So Olinda Rubio has $8,601 invested in Kohl's stock and Best Buy stock. Okay, Kohl's stock currently sells for $52 per share, and Best Buy stock for $27 per share. Now, Olinda has a total of 188 shares of stock. How many shares of each stock does she own? So now, in a typical algebra class, we would set up two equations, and then we could use the method of elimination or a method of substitution to solve. Okay, but let's use the echelon method to solve the system of equations. Okay, so we've got two constraints here. We got one, the total number of stocks, or shares rather, has to add up to 188 shares. Okay, so if you take all the Best Buy shares and all the Kohl's shares, then those two amounts should add up to 188. Then we also have the price per share. Okay, so we know that the total total cost of the shares is 8601. Okay, so we know that $27 times the number of shares of Best Buy stock plus $52 per share times the number of shares of Kohl's stock, whatever those two dollar amounts are, they have to add up to 8601. Okay, so this gives us our two equations, one dealing with the total value or total value of the stocks, and the other one dealing with the total number of shares of the stocks. And so if we look at this and we say, okay, let's make X the number of shares of stocks of Kohl's stock, And let Y be the number of shares of Best Buy stock. Now you could use K and B if you wanted to. You don't have to use X and Y. If you want to use K as Kohl stock and B as Best Buy stock, it's fine. So let's use X and Y as they have. So now here's our two equations that I just was talking about in words. So we know that $52 times X plus $27 times Y has to add up to the 8601. And then we also know that the number of shares of Kohl's and the number of shares of Best Buy have to add up to 188. So now we have our system of equations. So now all we have to do is solve the system of equations and we're done. So let's use the echelon method. So we've got it already in proper form. So now all we have to do is we have to eliminate this variable, the x variable. Well, the easiest way to do that is just multiply by negative 52. So if we multiply all of this by negative 52 and then add this to this. So if we add this to this after we do that, then this will eliminate this, the x term, and then we can replace the second equation with the new equation. So how do we do that? Well, just like I said. So if we do this, so 52 times this, we get, and then we add, so this is going to be negative 52 minus 52 equals, and then negative 52 times 188. And then we're going to add these two equations together. Well, in this case here, we're going to get a negative what? A negative 25 here equals whatever this turns out to be, and then we're going to divide by negative 25. And then we're going to divide this by 52. And so now again, do this on your own. So what you're going to end up doing is you're going to end up getting this here. Now again, they use decimals, but you could have fractions as well. Okay, so this would be x plus 0.52 y equals 165.4, and then here you're going to get y equals 47. Okay, now we've got it in the triangular form, and now all we have to do is use the answer for this one and back substitute. So we're going to stick in 47 for y, solve for x, and we get x is equal to 141. So that means that we just figured out how many stocks, how many shares of stock of each stock that Olinda owns. She has 140 shares of Kohl stock and 47 shares of Best Buy stock. Okay, now let's use another example. So let's say we have a restaurant owner and he orders a replacement set of knives, forks, and spoons. Now the box arrives containing 60 utensils and weighs 189.6 ounces, ignoring the weight of the box. Now, a knife, fork, and spoon weigh 3.9 ounces, 3.6 ounces, and 3 ounces respectively. Find the solution with the largest number of spoons. Okay, so now there are many solutions to this, but we want the solution that will give us the largest number of spoons. Okay, so how are we going to do that? Well, the first thing is we need to set up our system of equations. So here we've got two things going on. We know that it has a total of 60 utensils. So let x be the number of number of knives, let's say. Let y be the number of forks, and let z be the number of spoons. Now you could use k for knives, f for forks, and s for spoons, but again, you could use x, y, z as well. Okay, and so we're going to set up our system of equations. So here's the way we do it. So x is the number of knives, y is the number of forks, and z is the number of spoons. And so by the first statement here, we know that all of the utensils have to add up to 60 utensils. So the number of knives plus the number of forks plus the number of spoons has to add up to 60 utensils. Okay, so that's the first one. Now the second one has to take in the weights of each. Well, we know that a knife weighs 3.9 ounces, a fork weighs 3.6 ounces, and a spoon weighs 3 ounces. So we know that the total number of ounces has to be this. Well, if we take the number of knives times the weight of each knife, that's going to give us, this is going to give us the total weight of the knives. If we take the number of forks times the weight of one fork, that's going to give us the weight of all of the forks. And then if we take 3 ounces, which is the weight of each spoon, times the number of spoons, that's going to give us the total weight of all the spoons that are in the box. And so if we add up all of those 3 weights, they have to add up to 189.6 ounces. Okay, so now we've got our system of 2 equations. Okay, so now let's notice something here. We've got 2 equations, but we have 3 unknowns. So right away, we are going to have an infinite number of solutions. Okay, because we don't have enough equations to solve for z. Okay, so if we do the echelon method, we solve, we're going to eliminate the x variable, okay, but we're not going to be able to eliminate the y variable. Okay, so the best we can do is eliminate the x variable, and then and by doing that, we can multiply by negative 3.9. So we can multiply this equation by negative 3.9 and then add it to the second equation. And that's what they're doing here. So 3.9 times row 1 plus negative row 2. Okay? Or they could just do negative 3.9 here and just add it to this. So again, there's different ways of doing this. So we do 3.9 times row 1 plus negative 1 times row 2. And then we're going to take that and replace row 2 with it. And so this is what we end up getting. So notice that row 1 was unchanged. And so now our new row 2 is this. Okay? So now what? Well, we can take this and make this into a 1 by dividing by 0.3. So if we take this, again, take 1 over 1.3, row 2, and then replace row 2 with it, we get this. And so now this is going to be our system of equations. Okay, now we got it in triangular form. But the thing is we can't solve for y or z. So that means z is going to be our parameter. Z is going to be the free variable, which means we can let z be any real number. And then as soon as we know what z is, then y and x will be determined. Okay? So now, how do we do this? Well, we're going to back substitute. So if we say z is our parameter, we're going to solve for y. So we know y has to equal 148 minus 3z. So now this is our rule for y. So z is free to be any real number, and then y is determined by this rule. Okay? So y is a function of z in this case. Okay? And then we could substitute this into the first equation, and then we get this here. Okay? And then when we solve this, we get x is equal to 2 times z minus 88. So now we've got x in terms of z as well. So guess what? Now we've got all of the points that is the general solution. So notice that we've put y as a function of z and x as a function of z because z is the parameter. And we want to make sure that the other 2 variables, x and y, are in terms of z. That way, we can make whatever we make z into, once we pick a value for z, we know what the other 2 values in the particular solution would have to be. So in this case here, here's our general solution. It's going to be 2z minus 88 for x, 148 minus 3z for y, and then of course z for z. Okay, where z is any real number. Now what we can do is we can be given any z value, and we know what the particular other values are going to be. Now, okay. So, but what was the goal here though? Okay, so we got this general solution now. Let's go back to the question. What was the question? Find the solution with the largest number of spoons. Okay. Well, how do we get the largest number of spoons? How big can z be? So now, well, let's go back. We've got 60 utensils. So these are what we call the constraints on the system. So there can only be 60 utensils. So the most utensils you can have, or excuse me, the most spoons that you can have is 60, right? That's if you have no knives or no forks. But also the weight can be no bigger than 189.6 ounces. So we need to use those two things to help us here. So now, let us investigate what values z could take on. So this implication demands that the solution be non-negative integers. Okay? We have to have non-negative integers. Right? So that means the number of forks y in this case cannot be negative, which means it has to be bigger than 0. Well, if this has to be bigger than or equal to 0, right, because the number of forks can't be negative, right? So that means we're going to set this equal to 0 and then solve for z. And guess what? Solving this means that z has to be less than or equal to 49.33, which means that the most spoons you can have is 49 spoons. Okay? Now, what about the knives though? Well, let's do the same thing for knives. You can't have negative knives either. So that means this has to also be bigger than or equal to 0. But now this one solves and we get z is greater than or equal to 44. So let's look at this. This has to be less than or equal to 49.3. But also, z has to be bigger than or equal to 44. So therefore, the permissible values of z, which is the number of spoons, can only be 44, 45, 46, 47, and 48, and 49. So in this case, there are a total of 6 solutions that will give it to us. Okay, now, but the largest value, right? Remember, that's what they want. What's the largest number of spoons? The largest number of spoons is 49. Okay, from which we find that x has to be equal to what? 10, and y has to be equal to 1. And so the particular solution that answers the question that was asked is 10 knives, 1 fork, and 49 spoons. And that's the end of this section. So again, make sure you go through these and do them on your own, and make sure you're able to get the correct answers, the correct solutions. If you don't, if you end up getting the wrong answer, or you're confused, or something's not right, or you're not getting it, write your questions down, write it down, and bring it to class, and we will work on it in class. Okay, that's where the learning is going to happen, is in class. But you need to make sure you watch these videos. So again, I'm going to reiterate this all the time. This is a flipped classroom. It's not more work, it's different work. You got to buy into it and realize that by watching these videos and using your time in class to practice, and get your questions answered by the expert, me, the professional educator, right? oh my gosh, I can't talk. The um, the facilitator of the classroom. That's where learning happens. Okay, so again, I'm going to keep saying this. You need to buy into that this is going to be flipped, which means that you're going to watch the videos and come to class ready to learn and practice and ask questions, because this is going to be based on you. This is a student-centered method, okay, which is better, okay? It's not more work, it's better work. Okay, till then, have a great day, and I'll talk to you next time. See you in class.